Welcome to the video. Today I'm going to be messing around with firewalls in my home lab environment and doing some testing between networks to check to see if the firewall that I've set up is proper and does what it needs to do. So we look at my network that I've got set up here. I've got my pfSense machine, and in this particular environment I've got a LAN with the network over here, and I've got an opt1 with the network over here. My Kali machine here is in the 192.168.5.0 network, and then I also have a let's see, I've got Ubuntu here. Open up the terminal. Both networks have DHCP turned on, so depending on if my machine has auto DHCP enabled, it will just be given an IP address. So let's check right here. Okay, so I'm also a machine inside the opt1, the same network as Kali, so 5.44. I want to send some packets from the opt1 network over to the LAN side, but I'm going to sort of role play that I don't know what those rules are at all. And we're going to try to do some discovery and validate what is being shown to us. So we're kind of like pretending that we're an attacker and we're doing some reconnaissance. Now the actions that we're doing right now are not quiet. Doing a network scan is not a quiet activity. Sending hping3 packets is not quiet. So forget that part of it. Okay, what do we know so far? As a person that's landing on this particular network, I want to get a good idea of who I am. So the first thing I would do is check out my IP address, and Kali has a 192.168.5.41 /24. That means as well that we have a total host range in this class C. So we have a total of 253 machines that could be on this this network. Now that might seem inconsequential, like okay, great, it's class C, but it does tell us something about the people that design this network. It means that they have a particular scope, and they don't actually want it to be any bigger than that. This was a class A, and it was a /16. We know that there is a potential to have quite a bit more hosts on this network. It does tell us something about the structure of this. And an important piece of this is that we're trying to do some discovery out on this network, on other networks. Maybe there's another network segment that is also a class C network, potentially. Let's do a general network scan of our internal network that we're currently on. Not too hard to do. Do a general networks nmap scan here, and you're going to just do a stealth scan. Sound it out to everybody on this particular network, and we've got 5.1, so that is my gateway. That's my gateway, and we've got 44 and 41. And remember, our IP address is 41, so we've got another machine on this network. We know it's Ubuntu. Aggressive scan on the other machine in this network. Now, it might come back as nothing, and that's because I'm working in a home lab. I would have set up this firewall as a deny all, and I mean, it's not exciting YouTube stuff, but it will prove a point that you should set up your firewalls as a deny all. We really don't know what's going on over there. Let's actually jump over to that machine and take a look at the firewall that's on that machine and see, like, maybe that's what's causing this confusion here. my current zone is test. Let's look at it. And it's set to drop everything. I don't even know if I have any ports open on here. I've got I have a port that's allowed through, but I don't have anything running on this machine to actually allow that traffic through. There has to be something on the machine that is listening, a server or an application that's a server, and saying, hey, I'm listening, please connect with me. But you saw in the scan that nothing was detected. We've got a port listening. If we were to do that same scan here, this time we'll change the range, port 100 to 600. We'll come back and we can see that that port's open, right? So you gotta have something listening. You gotta have the firewall to come through, and you'll be able to see it. For giggles, let's have that running, but remove this. So the service is still running, but there's no port allowing it through. Let's do the same action again, and we'll see that nothing is open. It doesn't matter that there's a server running. You need to have a firewall rule on that machine allowing traffic in. Okay, so there you go. Nothing's open. Great. That's what a firewall should have. I feel like this is a really good example of why a firewall on every asset in network is absolutely critical. Just throw one on there, set it to deny all, and you're gonna be having a happier life. Let's scan that gateway again and see what those ports are again, because I need a reminder. We've got HTTP, so it's a gateway, which is just going to be connecting us to that router, and all routers have a web server running on it. So that's a potential point of compromise right there. And then we have a domain. So what does that mean? Okay, well, it means that in this particular network, there is the potential for assets that live here to be part of a domain that is connected somewhere else. We know that there's no domain controller in this network. We did a network scan, nothing's present. Okay, we've got Kali and Ubuntu. However, there is a firewall rule on the router saying that authentication is potentially happening somewhere else, a domain. What that domain is at this point, I don't know. There's a whole slew of ways to do this. But we would have to know the network that that machine would be in. And I know that it's not going to be a 5. Okay, so that's kind of out. And we do have quite a few like numbers that could be a potential network. I'm going to go with the assumption that this administrator used a class C for the other network. And so we're going to actually design a test to see what happens. Now, I really enjoy a tool called hping3. Once you use it a bunch of times, it's super straightforward. But you can do all kinds of things. You can do flooding. You can do just sending a single packet and seeing what happens. But we know that 53 is open, so I want to send something through that to a machine on the other side of the network. Okay, hping3. I'm going to do a SYN packet, and I want to do a single SYN packet, port 53 and 192.168.1. We're going to start with 1.1, and we'll see what comes back. And nothing came back. Okay, that's fine. So that tells us that a SYN packet went and it didn't go anywhere. We got it just sort of it died because there's nothing there to receive it and have it come back. As a case in point, if I were to do a 5.1 here, look at the difference here. That shows me that a SYN ACK came back. That was something that's actually receiving traffic and responded. A connection can be established, but nothing happened on the 1.1. So what do we do here? Well, I mean, I'm a resilient network analyst. I'm a resilient attacker, and I'm going to cycle through all the potential networks and all the potential hosts that could be on the other network. Now you're thinking, whoa, that's a lot of testing, and you're like, the truth is, yeah, that's the case. But if I've got the time, I'm an APT. Well, why wouldn't I send a single packet every other day to do a test? Every bit of information is still important information. Okay, so let's do that. I know a machine that exists in the other network, but we're gonna role play that I've gone through hundreds of different IP addresses to finally discover that particular network. And we're going to change the IP address here. We did 1.1, let's do 2.1. Nothing comes back. So now I'm imagining that I went through all 253 hosts on the 1 network. Now I'm going to the 2 network and going through all 253 on that. So effectively by the end of this, I would have done close to 500 different packets. Great. Let's go and cycle through and see what happens. All right. I know it doesn't look like much, but it tells us quite a bit of information. It means that from the LAN, so the 5 network, going to the 2 network, a packet is allowed through, and we know that there is in fact an asset on that network with this particular IP address. So let's update our hideous diagram here. 2.2. And we also know that I was using a class C IP address, so we also know that's a class C network, which is very informative. Okay, so that's the network. I know that I've got that asset there. I don't know any other assets at this point, but we're going to do some more testing to see what we can find. This could be the domain controller. Okay, I don't have any other. I need more information, but because I was using that domain port on the router right here, 53 was open, 80 was open. This machine literally responded with a SYN ACK from 53. So this is this is most likely a domain controller machine. Awesome. We've discovered something about a different network. Beautiful. Let's do a little bit of testing on our new domain controller. There's something I want to test first on this domain controller, and it's a really easy test, and it does tell us some important information. I'm going to 192.168 send an ICMP packet to that machine. I've sent an ICMP and nothing is happening. Okay, so what does that mean? Well, it can mean a couple things, right? Most domain controllers have a firewall. They should have a firewall installed. So a packet, ICMP packet, could be denied at the server spot. Okay, we could be having a firewall that's being stopped right here. Another spot is, remember, we're transmitting data through a router. Another logical spot to have ICMP being stopped or not allowed is right here on the router. Okay, so we can kind of guess here, router, ICMP denied, maybe. Let's look at the DC ICMP denied. And see if, oh, see, there you go. It doesn't, we're being blocked, or pings are being stopped. So we have to actually from now on take that off, take pings out. Beautiful. Now these are the ports on the actual domain controller. We've got 53, mm, 53, TCP, open, 88, TCP, open, 135, TCP, open, 389, TCP, open, 445, TCP, open. Beautiful. Whenever I'm dealing with LDAP and I'm on a engagement that doesn't require quiet behavior, I like to run Nmap. So let's run Nmap. Scan that I enjoy doing script. We're gonna run a whole slew at this guy here. Root. Run it correctly. And that's going to be a thing for us here that I got to remember to do that. Turn the ping probes part off. All right, so what do we know at this point? Or what kind of information did we get? Quite a bit. Beautiful. We know the domain of the server that we're working with, okay? And we even know the computer name here. So this is pretty useful. With that, we have a lot more to go with. Okay, there's a number of tools that we can use to do some scanning, but we don't know if there's anybody else. We know that we can reach out and touch the domain controller safely across the firewall. Why don't we do a Nmap scan of everybody else that potentially could be in that network? All right, fire it away. Oh, this is interesting. Some interesting things here. We already knew this guy. 2.2 is the domain controller. Scroll down. 2.6, nothing. 2.27 responded. We'll make a note on 2.27. We don't know much about this machine just yet. We do know that we likely can't ping it. Let's try it. It's going to hang forever. So again, that's either a firewall issue on that machine itself or a firewall rule on the router. I'm banking on the router. Yeah, it's a bit confusing. I know that machine is there, but we can't really do much on it because the ports are closed. So let's take a look at the router now. And let's look at what the firewall rules are saying, right? Let's see if some of our assumptions are correct. Okay, let's open up our router, and we've got the rules open right here. Now we're going to go over to opt1. Now this is the network that has the Kali currently in it and the Ubuntu, and we can see some relationships here. Right away, the very first one, we have everybody inside of that opt1 network is able to communicate with 2.2, which is our domain controller. So we know that. And then we have some of the ports that are allowed through. And that's why we can see these ports open when we do a network scan. Now, this one's closed. We have our 53, which is DNS, which is UDP. And then we have some ports connecting to the domain controller in the range of 49,000 up to the toppest to the top available range, and those would need to have a server running on it, but this is a potential connection point as well. And then everybody in the Kali machine could technically actually connect to the internet. So this makes sense that we couldn't see anything about the open ports on 2.27 because there are no rules allowing us to actually connect to those ports that are on that network. Maybe those ports are in fact having a service running on them, but we can't actually connect to it because the firewall, in this case pfSense, is actually blocking that traffic from getting to that running service. So let's actually use pfSense to validate that 2.27 is in fact a real machine. Let's go to services, and because this is a router and it's got a couple networks running on it, we can actually see who's connected to it. Let's go and I'll look at the DHCP releases. And we've got 2.27. So that confirms that we did have a real machine that is in fact in that network. Another way that we can prove it is that I actually went onto ChatGPT and I actually asked it to build me a bash script that would send a single packet to a particular port and then have an input list of various IP addresses. If we look at my IP list here, I've got the whole range of the network that we're doing a scan on. And if we look quickly at the bash script, we're not going to go through and crazy explain it, but essentially what's happening is it's going to create a netcat and it's going to generate a single packet and send it to port 80. Let's actually run it and validate some information that we already actually know. We know that it's 2.27, so let's watch to see what it looks like as a response when something goes to that particular IP address. This would be another useful way to do some host discovery on a network. Again, it's generating noise, so this would be very visible in a Wireshark. Let's look at, we got 25, 27, and we can run through this entire range, but look at what 27 looks like. Connection refused. Okay, whereas the other ones, it's connection timed out, which means it doesn't exist. So even though the connection has been refused, we know that something is actually there to receive that connection, which is very important. Okay, another technique to validate and prove that something is happening on the other side of that network. In a different kind of video, using some tools and techniques that we have on hand. If you're enjoying these videos, please go ahead and check out these videos that I've got on the screen here. I think you're going to enjoy them. All right. See ya.